A neutral wire is necessary running from the motor switch to the outdoor push button. While 120 volts can be obtained from hot to ground, it is unsafe to depend on the ground wire as a current carrying conductor. The ground wire's primary function is to provide a fault current path back to the source during a ground fault. Using the ground wire as a current carrying conductor creates a safety hazard by potentially energizing the electrical equipment's enclosure. The neutral wire serves as a return path for the current through the motor switch. Without it, current would flow through the ground wire, an unreliable current path. This can cause voltage drops and operational problems for the motor switch. Therefore, a neutral wire from the motor switch to the outdoor push button is important for the system's safe and proper operation. Consider the role of each wire in the circuit. Firstly, the hot wire provides the electrical potential to power the motor switch. It carries the alternating current from the source to the load, which in this case is the mechanism that operates the door. Secondly, the neutral wire acts as the return path for the current. It ensures that the current flowing through the motor switch can return to the source, completing the circuit. This balanced flow is crucial for maintaining a stable voltage and preventing overheating. Thirdly, the ground wire is a safety conductor. It is connected to the earth and provides a low impedance path for fault current to flow back to the source in the event of a ground fault. This rapid flow of current trips the circuit breaker or blows a fuse, disconnecting the power and preventing electrical shock or fire. When you use the ground wire as a current carrying conductor, you compromise its ability to perform its primary safety function. If a ground fault occurs, the ground wire may already be carrying current, which can prevent the circuit breaker from tripping quickly enough to prevent a hazard. Additionally, using the ground wire as a current carrying conductor can cause it to overheat, which can damage the wire and create a fire hazard. Furthermore, it can induce electromagnetic interference in nearby electronic equipment. The National Electrical Code, or NEC, provides guidelines for safe wiring practices. It specifies the proper use of grounding and bonding to minimize the risk of electrical shock and fire. Article 250 of the NEC covers grounding and bonding requirements. It emphasizes the importance of a dedicated equipment grounding conductor, which is the ground wire, and a separate neutral conductor. The NEC prohibits using the grounding conductor as a current carrying conductor, except under very specific circumstances that do not apply in this case. For example, NEC section 300.3 B requires that all conductors of a circuit, including the neutral, be run together in the same raceway, cable, or trench. This helps to minimize impedance and ensure proper circuit operation. Another relevant NEC section is 310.15, which covers opacity of conductors. This section provides tables and guidelines for determining the appropriate size of conductors based on the expected current flow and the ambient temperature. It is important to select conductors that are large enough to carry the load current without overheating. Another important NEC section is 400.7, which is about the uses permitted for flexible cords and cables. It must be suitable for the conditions of use and location. In addition to the NEC, local electrical codes may also apply. These codes may have additional requirements or restrictions based on local conditions. It is important to check with the local electrical inspector to ensure that your wiring installation complies with all applicable codes. A licensed electrician can ensure that the wiring is safe and code compliant. They have the knowledge and experience to identify potential hazards and to install the wiring in a way that minimizes the risk of electrical shock or fire. When wiring the outdoor push button, use appropriately sized conductors for the expected current draw of the motor switch. Consult the motor switch's specifications to determine its current requirements. Use weatherproof enclosures and fittings to protect the wiring from moisture and corrosion. Ensure that all connections are tight and secure. Label all wires and connections clearly to facilitate future maintenance and troubleshooting. Periodically inspect the wiring for any signs of damage or deterioration. Replace any damaged or worn wires immediately. When troubleshooting electrical problems, always disconnect the power before working on the wiring. Use a multimeter to test for voltage and continuity. If you are not comfortable working with electricity, consult a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. The importance of proper grounding cannot be overstated. A properly grounded electrical system provides a safe path for fault current to flow back to the source, protecting people and equipment from electrical shock and fire. Improper grounding can create a dangerous situation, increasing the risk of electrical hazards. Ensure that the grounding system is properly installed and maintained. This includes checking the ground connections for corrosion and tightness. Test the ground resistance to ensure that it is within acceptable limits. If the ground resistance is too high, it may be necessary to install additional ground rods or to improve the existing grounding system. Consider a scenario where the neutral wire is not connected to the push button. The motor switch might still appear to function if there is an alternate path for the current to return to the source through the ground. However, this is an unsafe and unreliable condition. The ground wire is not designed to carry continuous current, and it can overheat and fail if it is used for this purpose. This can create a fire hazard and can also damage the electrical equipment. Moreover, using the ground wire as a current-carrying conductor can interfere with the operation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect small imbalances in current between the hot and neutral wires. If current is flowing through the ground wire, the GFCI may not be able to detect a ground fault, and it will not trip to protect against electrical shock. It is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause the motor switch to operate inefficiently or to fail altogether. The amount of voltage drop depends on the length and size of the conductor, as well as the current flowing through it. To minimize voltage drop, use conductors that are large enough to carry the current without excessive resistance. Also, keep the length of the circuit as short as possible. When selecting conductors, consider the type of insulation. Different types of insulation have different temperature ratings. Choose an insulation that is appropriate for the ambient temperature and the expected temperature rise of the conductor. Also, consider the environmental conditions. If the wiring is exposed to moisture or corrosive substances, use conductors with a suitable corrosion-resistant insulation. For outdoor applications, use conductors that are rated for direct burial or for use in wet locations. When making connections, use approved connectors that are designed for the type and size of conductor being used. Ensure that the connectors are properly tightened to provide a secure electrical connection. Loose connections can cause overheating and can lead to electrical fires. Also, be careful not to damage the conductors when making connections. Nicking or cutting the conductors can weaken them and can create a point of high resistance. Another important consideration is surge protection. Electrical surges can damage sensitive electronic equipment, such as the motor switch. Surge protectors are designed to protect against voltage spikes by diverting excess current to ground. Install surge protectors at the server's entrance and at the motor switch to protect against damage from surges. The National Electrical Manufacturers Association, or NEMA, provides standards for electrical enclosures. NEMA enclosures are designed to protect electrical equipment from environmental hazards such as moisture, dust, and corrosion. Choose a NEMA enclosure that is appropriate for the location and the type of equipment being protected. For outdoor applications, use a NEMA 3R or NEMA 4 enclosure. These enclosures are designed to protect against rain, snow, and ice. Consider the type of wiring method used. There are several different wiring methods commonly used in electrical installations, including conduit, cable, and surface raceway. Each wiring method has its own advantages and disadvantages. Choose a wiring method that is appropriate for the location and the type of installation. Conduit provides the best protection against physical damage and environmental hazards. Cable is less expensive than conduit and is easier to install. Surface raceway is a good option for adding wiring to existing buildings without having to run wires inside the walls. In addition to the technical aspects of wiring, it is also important to consider the aesthetic aspects. The wiring should be neat and orderly, and it should be installed in a way that minimizes its visibility. Use cable ties or other fasteners to keep the wires together and to prevent them from sagging. Route the wires along walls and ceilings where they are less likely to be seen. Consult with the building owner or architect to ensure that the wiring is installed in a way that is aesthetically pleasing. When working with electricity, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools. Never work on live circuits. Always disconnect the power before working on any electrical equipment. Be aware of your surroundings and avoid contact with any conductive surfaces. If you are not comfortable working with electricity, consult a licensed electrician. It is better to be safe than sorry. And always remember that electrical codes and regulations are in place to protect people and property from electrical hazards. It is important to comply with all applicable codes and regulations. When in doubt, consult with a licensed electrician or electrical inspector. They can provide guidance on safe wiring practices and can ensure that your electrical installation is code compliant. Also, keep in mind that electrical systems can change over time. As buildings age, the electrical wiring can deteriorate. It is important to periodically inspect the electrical system and to make any necessary repairs or upgrades. This can help to prevent electrical hazards and to ensure that the electrical system continues to operate safely and reliably. Finally, remember that electricity is a powerful force. It can be used to power our homes and businesses, but it can also be dangerous. It is important to respect electricity and to take all necessary precautions to protect yourself and others from electrical hazards. If you are unsure about any aspect of electrical wiring, consult with a licensed electrician. They can provide the knowledge and experience to ensure that your electrical installation is safe and code compliant.